So, you're prepping for the ISTQB Generative AI exam, and you've probably noticed the syllabus throws a lot of terms at you. Well, today, we're going to cut light through all that noise and demystify the AI spectrum. We're going to focus only on what you absolutely need to know to pass. Let's get into it. And hey, don't worry about scribbling everything down. I've pulled all of this straight from the official ISTQB syllabus. Just think of this as our little focused cram session designed to help you walk into that exam feeling totally confident. Look, it is super easy to get lost in all the buzzwords: symbolic AI, machine learning, deep learning, generative AI. After a while, they can all start to just blur together. So, what is the actual difference, really? And more importantly, how does the exam expect you to tell them apart? That is exactly what we are going to break down right now. Okay, so here's how we're going to tackle this. First, we'll map out the whole AI spectrum to get the big picture. Then we'll dive into each one, starting with the OG, symbolic AI, and work our way all the way up to generative AI. And then we'll wrap it all up with a quick exam check to make sure these ideas really stick. All right, let's start with that big picture. Before we get lost in the details, we kind of need a mental map, right? This framework is going to help you place each type of AI, so you can see exactly how they connect and how they build on each other. First up, symbolic AI. I like to call this one the rule maker. This is really the grandparent of all modern AI. It's the foundation that everything else was built on, and you'll see it operates on a really simple logical principle. Okay, so what is it? For the exam, you've got to remember this key phrase: rule-based system. Symbolic AI is all about creating explicit, human-written rules. It doesn't learn on its own. We have to tell it exactly what to do. You can think of it like a giant flowchart or just a whole bunch of if-then-else statements. And here's a perfect example right out of a tester's playbook: password validation. The system isn't guessing what makes a password strong. Nope, the rules are hard-coded right in there. Must be 8 characters, must have an uppercase letter. Every time you test against those specific criteria, you are testing a form of symbolic AI. Okay, so if symbolic AI is all about writing rules, machine learning, or as I call it, the learner, is all about finding patterns. This is a huge shift in thinking. Instead of telling the machine exactly what to do, we're now giving it a bunch of data and asking it to learn for itself. So here's the definition you'll want to have in your back pocket. The key is that it's data-driven. It's this whole process of preparing data, training a model, and, this is super important, so listen up, feature selection. That's just a fancy way of saying a human has to tell the model which bits of the data are actually important to look at. We'll come right back to that. Think about a bug triage tool, right? This is a great testing example. With symbolic AI, you'd write a rule like, if the report contains the word crash, assign it to team A. But with machine learning, you'd feed it thousands of old bug reports and how they were solved, and it learns the patterns that predict whether a new bug is for the UI team, the database team, or someone else. It's learning from history. Now let's level up to deep learning, which I call the brain. Now, this is actually a type of machine learning, but it's way more powerful. It's designed to mimic the structure of the human brain to learn from these massive, complex data sets like images or audio. The key concept here is neural networks, which are modeled after our own brains. But for your exam, if there's one word you need to circle, underline, and highlight, it is automatically. Unlike classical machine learning where a human has to pick the important features, deep learning figures out what's important all by itself, straight from raw data. A classic example is visual defect detection on a factory assembly line. You don't program rules for what a scratch looks like. You just show the deep learning model millions of pictures of good products and bad products, and it literally teaches itself how to spot the difference. That is that automatic magic right there. Okay, everybody, pause for a second. This is huge. If you get a question on the difference between machine learning and deep learning, I can almost guarantee it's going to be about this. In classical ML, a human, you or a data scientist, has to do what's called feature engineering. You tell the model, hey, look at this column and that column. With deep learning, you just dump the raw data in and the neural network figures out the important features automatically. Manual versus automatic. Seriously, burn that into your brain. It's that important. And that brings us to the main event, the whole reason this certification exists: generative AI, or the creator. This is the tech that's changing everything, and it's a direct evolution of those deep learning concepts we just covered. So what is it? First things first, you've got to remember, generative AI is a type of deep learning, But its job isn't to classify things or make a prediction. Its job is to create. It learns all the patterns from all the text, images, and code it's been trained on, and then it uses those patterns to generate something completely new. I mean, what's the most relevant example for us testers? Using an AI tool to generate test scripts right from a user story. You paste in the requirements in plain English, and boom, it spits out Python or Java code. It's not just finding something that already exists, it is creating brand new code. That's the generative part.
Whew, okay, that was a ton of information, I know. So let's do a final exam check to make sure the most important points are crystal clear before we try a practice question.
Exam tip number 1, and this is a biggie. The single biggest difference between classical ML and deep learning is manual versus automatic feature selection. I guarantee you will see this concept on the exam in some form. And exam tip number 2, you have to understand the relationship. Generative AI isn't some separate thing from deep learning. It is a type of deep learning. Its special job, though, is to create new stuff, not just analyze what's already there. Remember it this way. All generative AI is deep learning, but not all deep learning is generative. All right, time to test that knowledge. A tester is using a tool to analyze screenshots to find UI defects. The tool was trained on thousands of images, but, and here's the key, it was never explicitly told what a defect looks like. So which type of AI is being used? Is it A, symbolic AI, B, classical machine learning, or C, deep learning? So take a second, think about it. What do you think? The answer is C, deep learning. So what were the clues? First, it's using complex data, images. And second, the absolute dead giveaway, it's learning the features automatically without any human guidance. That is the hallmark of deep learning. So I really hope this breakdown makes you feel a lot more confident for your exam. Go back, review these key differences, and you are going to be in